All right, here we go. Lesson 7.4, part 1. So you're getting part 1 today, you'll get part 2 tomorrow. Um, Today will definitely be the easier of the two. We are adding and subtracting fractions. Today is going to be with common denominators, and then the next lesson will be with unlike denominators. And that's where it gets a little bit tricky, trying to figure out creating the common denominators with these guys. So take you back to basics real quick. When you add two fractions together, if they have a common denominator, the denominator doesn't change. We just combine what's on top. Right, so for these guys, I'll give you real basic, some adding fractions here. So if I were to add 3/8 plus 4/8, right, we just add the top, the bottom doesn't change. So it becomes 7/8. Same works with subtraction. Remember, this whole chapter is about what we call rational functions, which means you're going to have an x somewhere in your denominator for these guys. So if I were to do 10 over x minus 3 over x, right? Again, I just combine what's on top. The bottom doesn't change. So it goes something like this. Don't forget basic rules. If I were to say, I'm going to say y over x minus, I'm going to say plus, keep it simple, plus 3 over x. So again, the bottom won't change, right? When you go to add stuff like this, remember your basic rules. Like you're not allowed to add something that doesn't have a y with something that does have a y, right? Addition and subtraction doesn't work that way. So if I were to say y plus 3, the one thing you can't do is write it as 3y, right? Because that would be multiplication. So instead, you would have to just keep it as y plus 3, since those guys do not combine together. So don't forget the basics. Let's jump one page ahead to page 208. Do a couple practice problems here, and then at the end of this, stay tuned in because I want you to see the end of this video, because I'm going to show you something that's going to really help with part 2 of this section when your fractions don't have the same denominator and you got to make them the same. So that's when it really gets fun. So take a look at these guys. You'll notice all 4 of these, they already have common denominators. So that's what's going to make this first part super simple. Remember what we talked about. The denominator does not change. All I do is combine what's on top. So on top, if I said 1 minus 5, and that's it. That's all you'd have to do for that. So jump on over to this one. Again, the denominator is already the same, and the denominator doesn't change when I'm adding and subtracting. All I do is combine what's on top. 4x plus 1x would give you 5x. Some of these will reduce, so that is something you have to check for. Take a look at this one. Again, my denominator is not going to change. It's going to still be x plus 4. When I combine what's on top, 6x plus 24, this one has an x and this one doesn't, so you cannot combine those together. I have to keep them as simply 6x plus 24 and write it this way. So here's one thing you got to check for on these. And if you don't look for it, you're probably going to miss part of the answer. So here's something you got to look for. If I were to factor the top, right? In other words, if I took out the greatest common factor, I know 6 can go into both of those. So I'm going to factor out the 6. Leaves me with x plus 4. Whoa, that's really ugly. Hold on. I'm going to rewrite that down here. So I'm going to factor out the 6. That leaves you with x plus 4. On bottom, I still have x plus 4. So now take a look and see what we can do to simplify this. Since I have a common factor, these guys can go, and my answer would just be 6. So that is something you have to look for. If you can simplify it, you need to do that. If you leave your answer like this, it's incomplete. So you got to be able to simplify it all the way through as far as it can go. So look for factoring, look for simplifying. This is a great one for you to try ahead of me. If you want to pause the video, give this one a shot. Remember, the denominator is not going to change. This one is x squared. This one is x to the first, which means they cannot be combined together. I have to keep them separate. So it looks like this. And again, I need to put this in factored form in order to see what can simplify here. So on top, remember we always start by looking for a greatest common factor. So I'm going to take out 2x. And that leaves me with x minus 7. On bottom I have x minus 7. Right, so notice I now have something that can cancel. If these are different and they do not cancel, then just leave it like this, right? That's the way you would write it if these were not common factors. So I'm just going to go ahead and get rid of those because they are a common factor, and we are left with just 2x as our answer. So that's kind of the highlight for today. That's the main idea, but I want to show you something that's going to help you with tomorrow's lesson. I put a couple problems at the end of your assignment today that you really need to do, because this is really the tough part going into tomorrow's lesson, or the next lesson I should say. So take a look at these top 3. What you're going to run into in the next lesson is, how do I add these guys together if the denominators are not the same? Right, and so all that is going to come back to making them the same. So we're going to be looking at fractions like this, and we're going to say, okay, well, what would my common denominator be? What's a value that 2x and 5x can both go into? Right, so, and again, it's not what goes into them, it's what can they go into. So I need some common denominator that both of those can go into. And what we call that is a common multiple. So, but if I were to have 9x to the third and this big ugly expression right here, I need to find one big giant factor that both of those can go into, right? A common multiple. And so the first thing we have to do on these is I need to put these into factored form before I can figure that out. So my first term is 9x to the third. I'm just going to bring that one down. So that's my first term. This is my second term, but I'm going to factor it by taking out the greatest common factor. So you can see that 3x can go into this, 3x can go into this, so I'm going to pull out the 3x, and that leaves me with x minus 7. Okay, so all we've done so far is put this into factored form. That's it. Now I'm going to look at my first term, and I'm going to look at my second term, and figure out what are these two things, what can these things go into. We're going to go down the line one piece at a time. I always start with my coefficients, so look at the 9 and look at the 3. What is a number that both of those can go into, right? And both of those can go into 9, right? So the one common mistake students often make on this is their answer will be 3 because they're trying to figure out what goes into these numbers, instead of looking bigger and saying, what can these go into, right? So I'm trying to find a number that both 9 and 3 can go into. That's my common multiple. Now I'm going to take a look at the x's. So I have an x to the third. I have an x to the first. All you're ever doing on these guys is you pick the one with the biggest exponent, right? So x to the third is something that both of those can go into. And now I'm going to take a look at what we call a binomial, the one with 2 terms, right? When it comes to the binomials, all you have to do on these is you basically just write everything that exists. So if I have a binomial of x minus 7, that just needs to become part of my common multiple, like this. All right, so this would be our least common multiple for these 2 terms, right? Because it contains something that all of this can go into. Let's try it again on this one. This one is tough because this one is just hard to factor. Before you can even figure out what your common multiples are, you got to put everything into factored form first, and that's tough to do with one like this because it's already hard to factor. So I'm just going to show you the factors at this point because I'm not worried about the factoring. We've already covered that this week. I want to show you what to do next. So there's my first term. This, if you were to factor it properly, and you can go back to Monday's video if you don't remember how to factor these guys, but if you were to factor that guy successfully, here's what it would look like. Your factors would come out to be 2x plus 1 as well as x plus 5. Okay, so here's my first term, here's my second term. I need something that all of that can go into. So let's just start with the one they have in common, right? So x plus 5 is something that they can both go into. I also need something that this guy can go into, right? So 2x plus 1. And that would be it. This would be our greatest common multiple, because this is something that this can go into. This is also something that this can go into. So I need one big factor that both of these can go into evenly. So let me give you one last problem here. If you want to try one on your own, this is a good place to pause. You're going to put this into factored form and put this into factored form, and then figure out what they can all go into. If you were to factor the first one, you get x plus 2, x plus 3. That's my first term. My second term would be x minus 6, x plus 3. So it looks like this. These are my two terms. I need something that all of this can go into. So I need something that both of those can go into. So I'm going to need x plus 2, x plus 3. I'm also going to need something that both of these can go into. Well, I've already accounted for this guy, right? He's already listed, so he's good to go. But I need something that this can go into. So I also need the x minus 6. So now I have one big factor, one big term, I should say, that both of those can go into and both of those can go into, right? And so that would be our greatest common, or sorry, least common multiple for this term and for this term. So definitely want to give those a try in the homework today, because that's going to be a super important part of our lesson part 2 that you're going to see next time. So until then,